and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 515, find largest value in each tree row. Before we get into the question, you guys know the drill. Please subscribe to the channel. It helps me grow. Alright, given the root of a binary tree, return an array of the largest value in each row of the tree, 0 indexed. So let's look at a super simple example. If we have this tree here, obviously on the first level there's only one element, so the root node is the largest element. So we would add to our answer a 1. On the second level we have two items, a node with a value 3 and a node with a value 2. Obviously 3 is bigger than 2, so for that level 3 is the largest element. And in the last level we have elements 5, 3, and 9. Obviously out of those three, 9 is the largest, so for that level we would add 9. So this problem is really straightforward and there's really no tricks to it. It's just going to be a straightforward breadth first search, doing a level order traversal of the tree, and we're going to keep track of the maximum that we've seen on each level. That's really all we have to do. This problem is really great for learning how to do a level order traversal because you don't have to really do anything complicated with the nodes. You just have to keep track of the maximum. So nothing really fancy here. All you need to do is keep track of the maximum. So every single level, we're gonna reinitialize our maximum variable to 0, or I guess minus infinity because we're looking for the maximum. And then what we're gonna do is we're just gonna keep track of the largest one. Once we've iterated over the entire level, we're gonna add that to our list here and then move on to the next level. So join me in the code editor. We're gonna figure out how to do this in a breadth first search manner, and I'll see you there. We're back in the code editor. Let's type this up. Like I said, it's really straightforward and a great way to learn how to do a breadth first search traversal. So the first thing that we need to do is actually check whether or not our root is defined. If we don't have a root, there's nothing in our tree, therefore there's no values, so we should just return an empty list. So we're going to say if not root, we can just return an empty list. Cool. Now that we've handled that edge case, let's set up a variable to actually track our largest values, because remember we have to return a list with the largest values of each row. So we're going to say largest values. It's going to be an empty list. Now we're doing this in a level order traversal and we use a queue for that. So we're going to initialize our queue. We're going to say collections.deck and we're going to put the root in there because that's the first thing that we want to process. Now what we're going to do is process our queue. So while we have elements to process, we're going to see that the maximum seen on this current level is going to be float minus infinity. And now we want to iterate over all of the levels in this, all of the items on this level. So we're going to say for blank in range lang q. So basically we're only going to iterate over the items on that current level, which is the number of items when we started our iteration for this level. Obviously we're going to be adding elements to the queue as we go through this loop, so we don't want to accidentally process too many. We only want to process what is actually on that level. And this is how we do it with this for item in range lang q. So now what we want to do is we want to get the item in at the top of the queue for us to process. So we'll say top equals q dot pop left. Now what we want to do is we want to check whether or not this top node's value actually is greater than the maximum that we've seen. If it is, we want to update it. So we're going to say max seen is going to be the, if I can just type today, is going to be the maximum of whatever the current max is and our top.val. Cool. Now that we've done that, what we want to do is if our current node top has a left and a right child, we want to add them to the queue for further processing. So let's do that. So we'll say if top.left, we're going to say queue.append top.left, and we'll do the same thing for the right child. So we'll say if top.right, we're going to say queue.append top.right. Now, once this for loop finishes, the last thing that we want to do on this level before we go into our while loop again is to actually update the maximum value. So we want to say largest values dot append whatever the maximum we saw on that level was, because remember on the next iteration it's going to get reset, so we have a fresh value for max seen, so we need to always put into our largest values array the value for that level. And once the while loop finishes, because there's nothing else to process, that means we have processed the tree entirely and we can simply return our largest values here. So our largest values, and I just want to run this, make sure I haven't made any syntax bugs or indentation mistakes, and it looks fine. All right, let us submit this, and it is accepted. All right, cool. Now that we know the solution works, what is the time and space complexity for this algorithm? Well, if you've ever done a breadth first search through a binary tree, you'll know that it's always going to be big O of n, where n is the number of nodes in the tree. Pretty straightforward. We have to touch every single node in order to basically process our tree with this while loop here. So that's why the time complexity is going to be big O of n. Space complexity wise, we have to maintain our queue here, which is going to be big O of n space to maintain the queue. And this is pretty standard. Anytime you do a breadth first search through a binary tree, it's always going to be big O of n time, and it's always going to be big O of n space, unless you're doing something funky in here, but you really shouldn't. If it's just a standard traversal like this, it's always going to be big O of n for both the time and the space. Anyway, that was a quick video on how to solve find largest value in each tree row. This is a relatively straightforward problem, great for learning breadth first search through a binary tree, like I mentioned a few times. If you enjoyed the video, please leave a like and a comment. It really helps me with the YouTube algorithm. If you want to see more content like this, please subscribe to the channel. I have a lot of videos already uploaded, and I don't plan on stopping anytime soon. So please subscribe and hit the notification bell so you don't miss those videos. Otherwise, thanks for taking the time to watch this video. Have a great rest of your day. Goodbye.